Hello friends, now let's today see role of oxidation state in inorganic qualitative analysis. If we want to separate a particular metal ion from the other ion, then we can change its oxidation state, and by doing so we can separate it from other constituent metal ions. For example, if we want to separate Fe2+ from other ions, on addition of OH- it will produce ferrous hydroxide precipitate, but its Ksp value is quite large and is equal to 4.8 into 10 raised to minus 16, and it is harder to reach. Therefore, we can change its oxidation state Fe2+ to Fe3+, and for that we use concentrated HNO3. After that, on addition of NH4OH and NH4Cl, it will form ferric hydroxide precipitate. Since its Ksp value is 3.8 into 10 raised to minus 38, which is quite small and can be easily reached, and that's why we get precipitate of ferric hydroxide. In that way, we can separate Fe2+ from other constituent metal ion, and this is the role of oxidation state in inorganic qualitative analysis. Let's see role of pH in inorganic qualitative analysis. pH is negative log of H+ ion concentration. If we change concentration of H+ in a mixture of two or more metal ions, then certain metal ion can be precipitated, and this is nothing but the buffer action. Let's explain in some easy way. Suppose we have been provided with two metal ions Fe3+ and Mg2+, whose concentration is 0.01 molar. Then, on addition of ammonium hydroxide of 0.1 molar concentration, both of them will form hydroxide precipitate. Why? Because due to addition of 0.1 molar NH4OH, the pH of the solution is equal to nearly 11.5 or 11.3 somewhere. To form precipitate of ferric hydroxide, we need pH 3.5. But to form precipitate of magnesium hydroxide, we need pH value of 9.3. But on addition of 0.1 molar ammonium hydroxide, the pH of 11.3 is reached, and hence we get both precipitation. But on addition of ammonium hydroxide with ammonium chloride, due to the common ion effect, the concentration of OH- ion gets suppressed, gets reduced, and hence due to reduction in concentration of OH-, pH also gets reduced, and we only get precipitate of ferric hydroxide and not of magnesium hydroxide. Why? Because due to addition of ammonium chloride in ammonium hydroxide, the pH reaches up to 9.25. See, pH is 9.25 and we need 9.3 value to get precipitate of magnesium hydroxide. And hence, in this way, the role of pH is quite important in inorganic qualitative analysis. Now we will see role of complexing agent in inorganic qualitative analysis. Suppose we have been provided with Cl minus ion and we know on addition of AgNO3 silver nitrate, it will get precipitated as AgCl, white color precipitate. But further, on addition of ammonium hydroxide, it forms a complex diamine silver chloride, which is soluble in water. And this test is used to confirm whether chloride ion is present or not. And in this way, this is nothing but a complex. And role of complexing agent is quite important in inorganic qualitative analysis. Another example is, let's say you have been provided with 3 metal ions. On addition of NaOH, which is a base, all will get precipitated as this. Okay, but on excess addition of NaOH, if we add in excess, only FeOH thrice will remain in a precipitate form, but other two, that is zinc hydroxide and aluminium hydroxide, will get dissolved because they form a new complex, sodium zincate and sodium aluminate, which is soluble in water, and FeOH thrice remain in a precipitation state. Third example is, if you have been provided with copper and Fe3 plus, on addition of ammonia, which is a base, we have to add it in an excess, FeOH thrice, precipitate will definitely form, but copper on excess addition of ammonia will form tetraamine copper sulfate as a soluble complex. And in this way, we have taken 3 examples to explain how the role of complexing agent play an important role in inorganic qualitative analysis. Thank you.